Today we are going to learn how to segment objects in images and in videos as well. So this will be part 1 and it will be based on Segment Anything by Meta. You can see this playlist for other segmentation tutorials. So let's start with part 1, segmentation and images, and let's see the demo. So let's run a short demo and explain what we are going to do today. You can see here this image. It's composed of two elephants, a big elephant and a small elephant, and we would like to generate a mask of the area of the small elephant. So it can be achieved in several methods, and we will use the SAM, the Segment Anything model. First of all, we will use the out-of-the-box process of generating an automatic mask. And then we would like to do it more accurate, so we will use a point of the area. We will give the model a specific point in the area of the small elephant, and then we will send the point to the model and then generate the mask. And at last we will try another method of running a bounding box, sending a bounding box around the small elephant, and then generate the mask. We also try to combine both methods. Let's run and see the result. So in this specific code we are sending the position of the bounding box, and also we are sending several points that indicates the small elephant, and you can see here the result. There is another result that is more clear. As you can see here, this is the bounding box, and these are the points that I'm sending as argument to the model, and it generates a very good mask of the small elephant. All the code is here. We will do a step-by-step and code all the process. Of course, I will leave a link at the video description for the code. So let's start. So let's start with the installation. First of all, as always, I will leave a link in the video description for the installation instructions and for the code as well. So let's start with the installation of the Segment Anything 2. I will leave here a link for the GitHub repo. Let's open it. So this is the GitHub repo. You can find here all the information, and I will cover it deeply, step by step, starting with the installation. So first of all, we should open our Anaconda prompt. So here is our Anaconda prompt. And first of all, let's start with creating a new Conda environment. So here is the command conda create -n, that means choosing a name, and the name will be SAM2, and it will be based on Python 3.12. And just for this tutorial, let's name it SAM2 tutorial. Okay, so that will be our environment name for this tutorial. So let's run it and let's wait for the creation of this new Conda environment. And now let's activate it. Conda activate SAM2 tutorial. Great. Now as you can see here, down here, this is now our current environment. Let's go back to the instructions, and now we have to install PyTorch. So in order to install PyTorch, first of all you have to discover what is your CUDA version. So this would be the command nvcc --version. Let's run it, and as you can see mine is 12.6. In this tutorial we will install PyTorch 2.5.1, so we can go to the website and click PyTorch and inside the PyTorch, let's go to the previous versions. We can find it here, previous version of PyTorch. You can see that the last version is 2.6.0. I prefer to use 2.5.1, and here you can see for each of the CUDA version what is the relevant installation command. If you don't have a GPU card, you can also install the CPU. I have 12.6, the last one is CUDA 12.4, so this will be my command for the installation. Let's copy the command and let's go back and let's paste it. So now it will take about 2 or 3 minutes and it will install the PyTorch 2.5.1. Let's stop here the recording and jump directly to the next step. Okay, we're done, and let's continue to the next step. Let's go back to our instruction file, and the next step is installing these 3 libraries: Matplotlib, OpenCV, and Supervision. So I also add here the specific versions for this tutorial. So let's copy one by one. This will be the first one, the first installation, the Matplotlib. Great. Now let's install OpenCV. And at last, let's install Supervision. Great, let's clear the console, CLS. Let's go back to the instruction file. Now we have to install the segment anything 2. So basically you have to choose your working folder. For example, I will install it under C tutorials. So let's go to my CD tutorials. Of course, you can choose your custom folder. And next, we have to clone the SAM2 from GitHub. So we will use the git clone, and it will copy or download or clone the library into my local machine. It will take a few seconds, and after that we can go inside and we can see the list of files. Great. Let's go back to the instruction file. Now we have to install the SAM2, so this will be the command pip install -e and add dot. So let's copy the command, clear the console, and run this command pip install -e space and add dot. So this process probably will take a few minutes. And once again, I believe that we will stop the recording and jump to the end of this installation. Great, we finished the installation of SAM2.10. Let's go back to our installation guide, and now we have to download 4 checkpoints. So these are the weights. We have one for tiny, small, base, and large. So let's copy these 4 commands and we will download the weights. So we finished downloading all the 4 weights files, And I think this is the last process. Basically, let's create a folder for the code. All the Python code will be stored in this folder. It's an empty folder, and if you are copying my code from the link in the video description, you should store everything here in this folder, this code folder under the SAM2. And if not, you can code with me. We will cover all the parts for the processing of the segment anything 2. Finally, we have to do 2 more actions. First one is changing our IDE, the current environment, change it to our new environment. So we will click Ctrl Shift and P, and then we will choose Select Interpreter. And now sometimes it will be the last one, and sometimes, as you can see, it's sorted by the Python version. So we are looking for the SAM2 tutorial. This is the one that we just created, so let's choose it. So now this would be our current working environment. And the next thing is change our working home folder to the SAM2. So we have to click here, File, Open Folder, and we have to go to the C, the folder that you put the SAM2. I put it on Tutorials here, and here is SAM2, and select folder. So now, as you can see, our current folder is the SAM2, and all the code will be stored here in this code subfolder. So everything will be here, and if you download my code, you should store it here on the code folder. So let's start with the coding. We will start with creating a new Python file. Let's name it step number 1, generate auto mask. And basically the goal here is to generate all the possible segmentation mask from a single image using the SAM2. So we are going to generate all the possible masks for a given image. Let's start with importing NumPy, PyTorch, Matplotlib, and OpenCV. And after that, we will create a random seed that all the results will be reproducible. Great. Now we want to ensure that we are using the right device, GPU if available, otherwise a CPU. And now we will copy some help functions from the SAM examples. So I will leave a link for an example in the GitHub repo. So you can go to this example and copy the relevant help function. It will help us to display the results more clear. So let's copy this function and let's paste it in our code. Now we load the input image. I'm using an image of an elephant here. You are free to try any other image. After loading the image, we should convert it to RGB for Matplotlib, and we will display the original image just to see what we're working with. So let's run it and see the result. Great, these are both images. We're going to focus on the small elephant. Now let's continue. Let's fix the direction of the slash, and also we don't need to display the original image. Now comes the cool part, loading the SAM2 model. We will import the build SAM2 function to create the model, and also the SAM2 automatic mask generator to generate the masks. Next, we'll define two variables. The first one, SAM2 checkpoints, is the checkpoints of the model, and also we will add a configuration file. And don't forget, you need to download the checkpoints manually as part of the setup and the installation. Let's now build the model. We pass the config, the checkpoints, the device, and also disable post-processing for raw masks. And after that, we will create the actual mask generator using the model. And now it's time to generate the masks. This will run the SAM2 model on our image and return a list of masks. Let's print out how many masks were generated, and this will give us an idea of how detailed the segmentation is. And let's also pick into the first mask and print its area. The mask object is actually a dictionary with a lot of useful info. I can see I have some syntax errors, so let's fix the name of the functions. And also the YAML file, let's copy the right path for it. So let's copy and paste it here. We can delete the SAM2, but it's under configs, right. So now we are ready, let's run it and see the result. Let's wait a few more seconds. So we have 50 masks, so this is the area of the first one, and these are the keys of the dictionary. Great, let's continue. Now let's display the segmentation mask on the top of the original image, and we will use our show_annotations helper to overlay them. And once again, let's run the code. Let's wait a few more seconds to see the result. We're expecting to see a lot of masks over the original image. So here is the result. You can see many masks in different color of the big elephant and the small elephant as well. Let's continue. So now let's generate a specific object using points. Let's create a new Python file and let's name it step number 2. And now we will generate a mask based on point. So part of the code will be sending an X and Y coordinates that mark a specific object in our image. So let's import OpenCV, and after that we will load the image that we would like to segment. I'm using the same elephant image here, but you can swap it to any image of that you like. And let's load the image. Let's make a copy of the image, that in that way we will not modify the original image while drawing on it. Next, we will define a mouse callback function that gets triggered when we click on an image. And if we left click, that's the L button down event, it will draw a green image circle at the click point and print the coordinates. And after that, after this function, we will create a window that shows the image, and we hook up the mouse event handler to it, and display the results along with the XY coordinates in the console. So let's run step number 2. Basically, it's part 1 of step number 2, which is learning how to mark a point on an image. So let's run it. So this is our image. Let's move it a little. Okay, so this is our image. We can see the big elephant and we can see the small elephant. And basically in step number 2 we would like to mask the small elephant. So let's click in this position, and our code points a green dot, and we will capture this dot, the dimension of this dot. Let's resize our image, and we can see here that the point selected is on these coordinates 1476 on 830. So these are going to be the coordinates to mark our small elephant, and we will send these coordinates to our SAM2 model in order to mask a specific area. So let's continue for the next Python code. Let's create step number 2b, generate a mask for a specific object, let's say using points. We will start with importing the relevant libraries. Let's copy it from our previous code, and after that we will bring in some helper functions from the official SAM notebook. After that, let's load our image. Basically, I believe we can copy all the process from our previous code, load in the image and display the image. And next, we will load the SAM2 model using its config and checkpoints. So we will use now the SAM2 image predictor. Let's copy once again the checkpoints and the model configuration file. And let's build the SAM2 model with sending all the relevant arguments. Now let's create the predictor class, and now we are ready to send the image to our predictor. Now let's try a single positive point by clicking on the small elephant. So we will send the coordinates that we retrieved in our previous code, and those coordinates means a positive value for the label. So that is why we are sending an input point of the X and Y, and after that an input label with the value 1 for a positive value. And at last we will display the image with our input point. And after that, let's print, let's do a quick check on the internal image embedding shape. I believe it will give us more info about the process. So let's run the code. So we are expecting to see two images. Here we are displaying the original image, and here we are going to display using the show points function. So basically it will be the same image, but we would like to double check that our point is on the small elephant. So we are still, before generating the mask, just double checking that we are marking the specific small elephant. So let's wait a few more seconds. And great, as you can see, we have two images. This is our original image, and here, let's move it a little bit, and here we have the same original image, but we have a star marks the small elephant. Great, so I think we are ready for the masking process. Now let's predict the masks for our selected point. In order to do that, we will use our predictor. So we are expecting to see three return values. the masks, the scores, and the logits. So we will use our predictor class, and we will run the predict function, and we will send the point coordinate. We are going to send only one point, the point label, basically it's a value of 1, and a multi-mask output true, and that will get 3 different mask options. And after that, let's print how many masks were generated, and also let's print the shape. So let's add a print statement for the length of the masks and also the masks.shape. I can see that I have a syntax error. Let's fix it as well. Let's run and see the results. So basically, of course, the step 1 will be displaying the image with the mark star on it. So let's close it, and now we're expecting to do the prediction, and you can see it's generated 3 masks, and here is the shape of the mask object. So as you can see, it's composed of 3 masks, and this is the dimension, the width and the height of each of those masks. So basically they are images that contain a mask with this dimension. So let's display those masks. So we will use the function show masks, and we will send the image, the masks, the scores, what else? The point coordinates, it will be the input point, and of course the input labels, and let's also add the borders true. So the borders true. And now let's run it again and let's see the result. Hopefully we're expecting to see 3 masks, 3 predicted masks. And this is the first mask, and this is the score of this mask, 0.8. Let's see the second one. Wow, this is better. This is a better mask. And let's see the last mask, and this is the last mask. Now let's use another method to annotate the results. Let's use the Supervision library, a very great library for doing object detection and segmentation processes. Let's load again our original image, import Supervision. We will start with create a box annotator using the box annotator class. The color_lookup ensure that different objects get different colors based on their index in the detection list, and this keeps your annotation visually clear and consistent. And similarly, this creates a mask annotator that overlays segmentation masks on the image. Again, using color lookup index lets each mask to get a distinct color so we can tell them apart easily. After that, we will define a detection object, which is a core abstraction of the Supervision library. It expects a bounding box in XY format and then an actual binary mask. And after that, let's annotate the original image using a bounding box. The scene equals image_bgr copy means we draw over a copy so the original image stay untouched. The annotate function adds the boxes and optional labels very clean and fast. As for the segmented image variable, same idea here, but now we are applying the segmentation mask on the top of the image. this produces an image with a beautiful colored overlay showing its segmentation object. The plot underscore images grid, this show the original versus segmented results side by side. And after that we will display the three predicted masks with their confidence score. So the score will be part of the title. Now let's move one step ahead. Let's try using multiply input points to get a more accurate mask for a specific object. So I have already a list of points that mark the small elephant. So let's copy and paste them. And now let's do a similar process. Let's grab the mask input from the most confident mask from before. And let's do once again a prediction now with a multiply points and the previous mask as an input. So this will give us a more accurate result. So we are sending the points, the list of points, the list of labels, basically all of them is one, and also a mask input. And the result will be stored in the masks and in the scores variable. So after that we are ready to print the result, and let's also display it on our image. So we will use the show mask again. So let's see the result now with the Supervision library. We will follow our previous steps. So first of all, we are expecting to see the two images, the original image and the one with the star. So here are the two images. Let's continue. Now we can see the three masks, same as our previous step, and from now let's double check the result. Here is our source image and here is our segmented image with the multiply points. Let's close this, and now we can see the three masks out of the SAM2. And let's see if there is another thing. Yes, this is the one that contain all the points. All the points we are now running it with multiply points. So here are the points of the small elephant. Great. So we segmented this as well. So the last Python file will be generating a mask based on a specific bounding box. Bounding box will be around our small elephant. So let's copy and paste as a starting point. Let's copy and paste our previous code and let's name it step number 3 using bounding box. Now let's look for our starting point. I believe it will be from the predictor. Yes, let's start from here. First, let's try predicting based on a just bounding box. So this box surrounds the smaller elephant in the image. Now let's delete all the irrelevant code. I think it should be enough. now let's continue with the prediction. We will pass in the box, leave the points as none, and ask for a single mask. As you can see, the box is equal input box, and the point coordination and the point labels are none. Let's delete all this as well, and we will need the show mask. Let's visualize the results showing the predicted mask along with the box. All the rest can be deleted. Great. Okay, so let's run it, but I see I have some problem here. First of all, I have to add a comma here, and I also can mark those lines, since the function show mask already doing this functionality. So let's run it. And now basically we are doing mask segmentation based on a bounding box. Great, as you can see, here is the bounding box and here is the mask. And of course we can do a mix of both points and the mask, and the bounding box. Just to save time, I already combine those points and bounding box in the code, so I just copy and paste it just to save time. So now, as you can see, here we have the input box, and here we have the points, the same as we have done earlier. And most important, for the predictor we are sending the points and also the input box. So now it will be more accurate. The points and the bounding box are pointing directly to the small elephant. And let's see the result. Here it is. This is the bounding box, and this is the point. Here are the points, and we have a great mask of the small elephant. Great, so our next tutorial will be on segmentation in videos. So stay tuned. Bye bye.